Hi everyone, welcome back to Lulumath. This video is on translating verbal expressions into algebraic expressions. And what we're going to do is we're going to take written expressions and write them in mathematical symbols to end up getting expressions, and sometimes we'll actually end up getting equations as well. So looking here, we have a chart that tells us some key words that we might see that represent the operations that are written in this chart. So addition, subtraction, multiplication, and division. And this document is available at lulumath.com. So if you want to print it off or have an electronic version of this document, please feel free to take it. The resources are there for you to take whenever you need it. I'm not going to spend the time reading out loud every single one of these key words, but I will zoom in on each section if you want to take a look at it. Pause the video if you want to take a closer look at what these different keywords might be. So here we have addition. Here we have subtraction. Here we have multiplication. And here we have division. And like I said, I'm not going to go through each one separately, but I do want to bring your attention to a few of these keywords that we see here. The first set is 2 more than a number and 2 less than a number. We want to be careful about these keywords because they're a little bit trickier, and that's why I have them written in bold. So when we say 2 more than a number, we have to know what the number is first. Or we have to write out what that number is first. So if we don't know it, we can use a variable for it. But regardless, we need to have that number written out first before we can add the 2 more to it. So for example, if I have $2 more than you do, and we don't know how many dollars you have, we would say X is the amount of dollars that you have, and then I would add 2 to that to figure out what I have. But if you notice, even though your amount comes second, we start with what you have first and then we add the 2 to it. Now for addition, it's not a big deal because addition is commutative. So if I say 2 plus x instead, although it's technically better to write it as x plus 2, it's not wrong because if I add 2 to x or if I do 2 plus x, they're going to give us the same result. Right? The bigger problem comes when I have subtraction, because if I have 2 less dollars than you, I still need to know how much you have first. So you have to have the amount written out first. And if I don't know it, I can just call it X, but I need that X first to know what I'm going to subtract 2 from. So for example, if you have $15, that means that I have $13. And the way I figure that out is if I take 15 and I subtract 2 from it. It does not make sense to write 2 minus x. This is wrong. And in this example, you can see why that's not going to work, because I'm not going to say 2 minus 15 and I would get negative $13 because I don't have negative $13. I have positive $13 and I have to take your amount first and then subtract 2 from it. So when we say 2 more than a number, we have to write x plus 2. And when we say 2 less than a number, we have to write x minus 2. This number has to come first, just like it did over here. A couple other things that I want to bring your attention to is just this twice a number and this double a number right here. This is not any kind of multiplication. It's only multiplication by 2, but we put it on the list because that tells us that we have to do some multiplication, okay? And same thing with this half of a number. It's not any division. It's specifically division by 2. But again, I put it on the list because it is a word that implies division. Okay, so we want to translate each verbal expression into a mathematical expression or equation. So in our first example, the expression says the sum of 4 and a number. And we know that the word sum means to add. It's in our chart for addition. And if we don't know what that number is, we would call it x. So here we would say the sum of 4 and x. So I'm going to add 4 and x together. Now, you can also write this out as x plus 4 because addition is commutative. So it doesn't matter what order you put it in for addition, but if we were to translate it exactly what this expression is saying, then this would be the more accurate representation. In our next example that we're looking at here, it says for more than a number. And when we have more than a number, that means that we have to add. But again, we don't know what that number is, so we will call it x. And we have to start with x first. This number goes first. So we will have x, and then for more than that means that we would add 4 to it. So this would be x plus 4. Essentially, these two expressions are saying the same thing. They translate the same, even though there's a slight difference. In our next example, we have 8 minus a number, and minus means to subtract, right? So if we don't know the number, we can call it x, we can call it n, we can call it any variable you want. So I'm going to change things up and I'm going to use n instead. So I have to write it exactly how I see it, 8 minus a number. So this is my answer right here. I cannot switch the order here because subtraction is not commutative. So it has to say 8 minus n. In this example, we have 8 less than a number. And less than also means to subtract. But we have to take our number first. We always start with our number if it's 8 less than a number. So we're going to say n, and then we're going to have 8 less than that. We always start with that n first, okay? So these are not the same. These two expressions are not equivalent. Let's work our way up now. So here, we're told that the product, and the word product is in our chart under multiplication, of 5 and a number, and if we don't know what that number is, we can call it whatever we want. So I'm going to call this r, just because that's what I want to do. Increased by, and when we're increasing a number, it means we're adding onto it. Increased by 7 is, and is also a really important word, even though it seems so minor. It's just 2 letters, but it's so important because this is right here means equals, and it's going to equal 12. So let's go ahead and translate this. So this is saying we're going to take 5 and we're going to multiply it because it says product. So the product of 5 and a number, and we didn't know what that number was, so we called it r. Next we have increased by, so we're going to increase it by, then it says 7, and then we have the word equals, and it tells us it's equal to 12, all right? So I'm going to use some arrows to show you where all of this is coming from. So the product right here of 5 and a number increased by 7 is this 12 that we got right here, okay? All right, in our next example, we're told that 6 less than, and we know less than means subtraction, the quotient, and we know that quotient means division, of a number and 9, and this next part is a little bit tricky, exceeds. And if something exceeds something else, it means it's more than something else. And if we have more than something else, then it acts as addition. And here we have twice the same number, and we know twice means to multiply the same number by 5, and this by 5 part right here is connected to the exceeds. It exceeds something by 5. So these go together. And if we don't know what the number is, we can call it whatever variable we want. So here I will call our number b. And I just randomly chose a letter. All right, so let's translate this right here. The first part that we have here, the 6 less than, we need to have what 6 is less than first. So we need this quotient of a number and 9 before we can write 6 less than. So this means I need to take a number. And since we have the quotient here, quotient means to divide. So I'm going to divide that number by this 9 that we have here. And now I can go ahead and do the 6 less than. So I'm going to subtract the 6 from here. Here is where we got to be really careful. What this is pretty much saying here is equal to 5 more than, and I got this 5 from this word right here, and it's equal to 5 more than twice the same number. So because we have the word is here, we can put an equal sign. And we need to write this twice the same number first. So I'm going to do 2 times x. That's where this twice comes from. The same number, and I apologize, I should do b because it's the same number and we're using b here. And then it's exceeding it by 5. So it means it's 5 more than that. So I'm going to write plus 5 right here. And this is the translation of my verbal expression into an algebraic equation. This time it's an equation and not an expression. All right, let's take a look at our last example right here. So we're told half, and half means to divide by 2. So we've got division or multiplication by a half. The sum of a number and 10, and sum means to add, is equal to, and that means simply just an equal sign. So this time the is equal to is a little bit clearer than other times. 4 multiplied by the difference, and difference means subtraction, of the same number and 3. So let's go ahead and translate this right here. So I have to take half of a sum. So first of all, I'm going to write the sum. And because it's an entire sum and I'm doing something to the full sum, I actually need to put this here in brackets. And if I don't know what the number is, I'm going to call it m. Again, just a random letter that I decided to use. So I have to write out the sum of m and 10. So I'm going to take m and then I'm going to add the 10 to it, but it's the full sum, so I need these brackets. And then I'm going to take half of this amount. So I have 2 options to write this out. I could either write 1/2 multiplied by all of m plus 10, or I could take this m plus 10 and divide it by 2. And here I have invisible brackets to imply that I have this m plus 10 all together. All right, let's keep going. And then the next thing we have here is equal to. So we'll put equals. And then it says 4 multiplied by the difference. So again, here's another example where we've got the word difference of an entire expression. So we need the same number and 3 being subtracted together. So here we're going to write m, and then we're going to put our difference, our subtraction sign. So we're going to say m minus, and then we'll have our 3 here. But it's 4 multiplied by the entire thing, so I have to have my brackets here. Now I can say equals here. I can just copy down what we have on this line up here, and either one of these expressions will work. And that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and please share with others. Thank you, and we'll catch you next time. Bye.